All right, welcome back. Now, I'm going to read this problem and then we'll attack it. So now we're going to talk about applications, right, where hyperbolas are used and can be used. So I'm going to read the example, and then what we'll do is I got the diagram set up already on the board, and then what we'll do is we'll start to analyze it and see if we can solve the problem. It says, suppose that two people located 3 miles apart at points A and B hear a clap of thunder. The time difference between the sound heard at point A and the sound heard at point B is 10 seconds. If sound travels 1,100 feet per second, find an equation of the hyperbola where the foci are at A and B, on which the point of origination of the sound must lie. Okay? Okay. Now, so here's what they give us. So I set it up. Here's point A, and here's point B. So there's where those two people are standing. Let's say here's the storm where the thunder happened at this point right here. And so they're equidistant from whatever the center is. So this is the center, right? And so 3 miles is 15,840 feet. Half of that is this distance here. So obviously the other half is this. Now what else other information they give us? They give us that the time difference between the amount of time that it took for this person to hear it and the time that it took for this person to hear it, the time difference is 10 seconds. Okay? So the time difference is 10 seconds, meaning that could tell us how that can give us the constant, right? Because we can use the fact that distance equals rate times time, because they give us the rate the sound travels, right? So the time difference, equals 10 seconds. And then sound travels at a rate of approximately 1,100 feet per second. Okay, so now let's use distance equals rate times time, right? So if we know the distance is equal to rate times time, and if we use also that d1, distance 1 minus distance 2 has to be constant, right? So, what do we get? Well, that's going to equal what? This. It's going to equal the 10-second difference right? Because if we do this, rate times T1 minus rate times T2, we get rate times T1 minus T2. That's the time difference. We already know what that is. So it's just going to be 10, right? So this is going to be just the rate times 10, which is just these two numbers. So that's going to be 11,000 or 1100 times 10, right? And the seconds are going to drop out, and we get 11,000 feet. So we know that this distance minus this distance is 11,000 feet. All right. Now, what do we do with that? Well, we use the fact that what do we know about that value, right? Remember from our previous videos, what does D1 minus D2 have to equal? It has to be 2A, right? Remember? So this is equal to 2 times A. Remember the distance from the center to the vertex, one or both vertices, right? So now that means that A equals what? $5,500 feet. Okay? So that's going to be the distance, right? So we got A, and we got C, and now we can find B. Right? So now, so this is C, right? The distance from the center to one of the foci, right? I think that's what they want us to do. Yeah, so they want us to find the equation of the parabola, right? So they want us to find the equation of a parabola for the sound where A and B are the foci of the parabola, and that using the time difference, that the storm, the thunder, where the thunder occurred has to be somewhere on that hyperbola, okay? So that's what we're dealing with. So this is the distance from the center to this foci. We know that that is 7920, right? It's half of this. And so that is also our C value, or excuse me, our C value, right? So C is equal to 7920 feet, okay? So we know C, we know A, now we just need to find B. Okay, so B is where we use our formula. B squared equals C squared minus A squared. So this is where we're going to use our calculator. And so you're going to use 7920 squared and then minus 5500 squared and subtract those two and then take the square root and you get approximately 5699. So where's my, oh, here it is. So here, so B equals the square root of, where's C? Oh, 7920 quantity squared minus 5500 hundredths squared. And when you stick this in your calculator, you get approximately 5699 feet. Okay, so that is your value for C. So that means the source of the sound must be at a point on the following curve, right? So now, based on this information and the fact that we're using this point wherever this point is, we know that this distance minus this distance has to be equal to 2a. That's how we got our a value. We got C because we know the distance between the two people is this, so halfway is the center, right? If we're assuming that these 2 points are going to be the foci of the hyperbola, so that gives us our A and C, and then we got our B here. Okay, so that means if we use this information to write our equation of the hyperbola, right? In this case here, we're going to go vertical, or excuse me, horizontal. So that means it's going to be x squared over 5500 squared minus y squared over our b, right? So this is b, 5699 squared is equal to 1. So where the thunder came from must be a point on the curve, the curve of this equation of hyperbola. Okay. If you have questions, let me know. But that's the way you do application problems. You figure out what is given to you, take that information, and then use that information to find all the pieces that you need in order to, in this case, come up with the equation of a hyperbola that basically gives us possible locations for where the thunder happened.